equal opportunity to everyone else.
Equal opportunity to lose it. I always provide.
Burn!
Burn!
I didn't get one in the first place.
You got one, I know I did, because you complained about that the last time I gave you one. Alright, so, pre-calc. The sections are on the board. 5-1 to 5-3, 6-1 to 6-2. These are the sections. You have 15 problems. The first page is probably the most challenging.
Yeah, I agree.
Honestly, the first time.
Our last test was 24 questions.
What's this one?
Yeah, that's 15. Alright,
This thing is huge.
so, it's not big.
This is a
Alright.
massive one.
And I give you a ton of
Neither do
Hey,
I.
you guys complain, that's my yard.
Mr. Ward, I found the test
Mr. Ward,
on chapter
I have a
6.
I
question.
found it, Mr. Ward.
Mr. Ward,
Mr. Ward, you should rate the test the
I have
same amount
some
of back when
difficult
pros
classes
back.
later on in the day, and I will probably mentally fried after fourth period. So guys, go home and
No.
do.
Okay,
Mr.
no.
Ward, that cherry coke is asking me off.
So-
Didn't save money there.
I thought it was only over,
Okay, hey.
I thought it was only over chapter 6.
Hey, let's go, guys. Otherwise, I don't have to review. That's fine. I don't need to do this. I know how to do it.
I don't though.
Okay, we're gonna go through this. When you start these problems, you need to pick the easiest side, and what you're gonna try to do, the easiest side, like when I look at this, I consider this kind of easy side. I want to turn this into that. That's basically what I want to do. It's very, very easy, very quick. Let's kind of walk through this. So if we're going to change these, this is where you have to use your properties. The rule is, when we're trying to simplify this, you want to get them to sines and cosines, and then you want to try to combine fractions. So like when I change tangent, tangent is sine over cosine. That's on your property sheet, you can see it. Cotangent is cosine over sine. So that's, and what I'm going to need to do next is try to combine these.
Where's this at?
What?
Where's this at?
On your property sheet? It's right in the middle, top of the page, right here. Like middle of the page, it's where all
You
the
put the
signs
box around it?
Yeah, put a big box around it. Alright, we're going to try to get this side, because that's a more complicated side, and we're going to try to turn it into this. Now, if you don't know what this side is, you are allowed to simplify the other side, but you're not allowed to drag things across the equal sign. Because I'm trying to show that they are equal. So if you drag them across, you're assuming they are. We don't want to do that. So the idea is that if you want to change these, you can. These are being multiplied together since there's no operation between them. So if you want, you could change these to be 1 over cosine times 1 over sine. You could change it to be that, and then we could see, does the left turn into the right side eventually. But let's do the math here. To actually get these to work out to be the same, we have to get common denominators to add fractions. So in this first one, I'm going to multiply by a sine on the bottom. And when I do that, I have to multiply by a sine on the top. That way I'll get sine, cosine on the bottom. Over here, I'm going to multiply by cosine and multiply by cosine. Because that way I get sine and cosine on the bottom. Because whatever you do to the bottom, you have to do to the top. So when I do this, on the top I get sine squared. On the bottom I get sine, cosine. Plus, over here I get cosine squared on the top, because that's cosine times cosine. And on the bottom I have sine, cosine. There we go. Alright. And now I can add them together because I have common denominators, and when you add, you just add the top. The bottom doesn't actually add together. So what I'm going to get here, so if I drag this over here, I'm going to get sine squared plus cosine squared over sine, cosine, because you don't actually add the denominators. The denominator stays the same when you actually add fractions. And what does the top actually make? If you look at your property sheet, sine squared plus cosine squared. 1. So if this turns out to be 1, I think you can see that the left and right side are now equal. Because on the right side here, this is what we had, and we simplified it to be this. This is the same thing. If you multiply the two fractions together.
So you're saying you should put it 1 over that?
Like change this right side here?
Yeah.
Yeah, you could, if you change the right side, because you can change both sides if you want, you didn't necessarily have to, because if you got it down to this point, you can move these up and make them the reciprocal functions. So you didn't have to work with the other side. It's just if you can't see it, you can work with both. It's just you don't want to drag things across. Okay? But you should be expecting, why I picked this problem, you should be expecting a problem where you have to be able to add fractions together. So you have to find common denominators, change the numerators and add straight across. There'll be a problem on there somewhere on this first page. You have to be able to do that. So that's why I'm providing you that. So you're getting some practice today to see that. Okay, questions on the first one. That's the style of problem that you're doing. Now on the next one, I'll kind of show you what we're going to do here, but there's, again, don't take it for granted like there's only one way to do it. There was a billion different ways I could have done that problem. You know, there's different strategies you can do. I'm just showing you the way that, the book prefers you to do it. This is the way that I was taught when I was in school to do it. So this is like the easy way, because you're just using simple properties to substitute. But you have to get really comfortable with your property sheet, and you gotta know what to substitute in. I always change things to sines and cosines, and then just try to combine things down until they look the same. That's what I do. I try to keep it as easy as possible. The next one, number 2, why I gave you this one. This one requires a conjugate rule. So it's gonna require a conjugate, it's gonna require that you FOIL and simplify using top and bottom methods. So it's got really 2 major concepts in here. This second one is significantly harder than the first one. Now, if you choose to do it the way that I can, that I'm going to show you. Now, if you choose not to do it by the conjugate rule, you would have to. You'll kind of have to anyway, unless you want to do a reciprocal, which is a lot of steps. But the idea is that some people, like when they see this problem, they change everything to sines and cosines right away. You can do that. That method, if you change that everything to sines and cosines on number 2, you won't necessarily have to do a conjugate rule. You can get away with doing a reciprocal. It takes a lot more steps than what I'm about to show you, just to show you that the signs do work out. So if you want to choose to do this problem like we did number 1, you could, and it would work out. On this one, I always choose the side that has a more complicated, so I'm going to choose this side. Why I consider this more complicated? It has a binomial in the denominator, so you can't have that technically.
That sucks.
So we need to multiply by its conjugate. So the conjugate of the bottom is taking the same object they have on the bottom and changing the sign in the middle of it. And that's what I'm going to multiply top and bottom. So I'm going to multiply top and bottom by that. Now, here's what I told you in class when we did these types of problems. Don't actually FOIL the top together, like distribute the top. Leave the top alone, it usually simplifies. That's the rule that we did when we used conjugate rule. So the top, I'm going to leave it cotangent beta out front, and I'm going to put beside it cosecant beta minus 1. I'm not actually going to multiply the numerator. The denominator I'll FOIL first, outer, inner, last, so we can actually do a little bit of substitution here. So first, cosecant times cosecant is cosecant squared, betas. Cosecant times -1 is negative cosecant beta. 1 times cosecant is positive cosecant beta. And then 1 times -1 is -1. Alright, so that's FOILing the whole bottom out first, outer, inner, last. Now what happens to the middle terms?
Cancel.
Gone. So what we're left with here is this so far. We're left with cotangent beta, cosecant beta minus 1, all over cosecant squared beta minus 1. That's what we're left with. Okay? On the bottom, if you do these correctly and you use a conjugate, that bottom should be a Pythagorean identity. So if you look at your property sheet and you look at the Pythagorean identities, I think they're right in the middle of that property sheet. We should have had a box.
Cotangent squared equals cosecant squared.
So say again.
It says 1 plus cotangent squared beta equals cosecant squared.
Okay. So this is the property that I'm referring to on your property sheet. Cosecant squared is equal to 1 plus cotangent. Why you're allowed to use this? Because you can, this is the Pythagorean identity, this is on your property sheet. You're going to use any manipulation of these. So if you want, you can like subtract this 1 across. So if I subtract this 1 across,
Still equal.
it's, they're still equal. And then this cotangent squared beta is equal to cosecant minus 1. So right here, you can see I have a cosecant squared minus 1. That's just cotangent squared beta. So I'm going to replace it. So on the denominator here of this, I'm using this. This is the rule that I'm using.
Do we need to note that, or can we just like...
So no, this is just something like I have to be thinking about in my head, like I'm looking at those Pythagorean identities. I'm going to replace, that's a cotangent by the way. Cotangent beta, cosecant beta minus 1, all over cotangent squared beta. All right. And yeah, that was a cotangent up here, not a cosine. I don't know why it's cosine. All right. So that's what I did. So I replaced the bottom, because we saw it in the Pythagorean identity, it was just a manipulation of that. That's what happens when you do conjugate rule. And on top and bottom, if you don't FOIL the top, which I told you not to, things simplify. You see it. There's things on top and bottom that are common. So if you do this correctly, cotangent should go away, and you get rid of one of these on the bottom, because there's two of them on the bottom, and that equals what you had up there. So the right and left side are equal if you do it correctly.
Oh my
This is by far the easiest way of doing it. It's the fastest, I should say, not easiest, fastest way of doing it.
What's the easiest way?
That's, I don't know, because I guess that's really subjective depending on what you consider easy. I'd say this is definitely the fastest way. For some people, they don't like that. It takes too many steps, they have to refer to the property sheet too many times. I've definitely seen people attempt this problem in years past where they replace all these with sines and cosines. Like this is 1 over sine minus 1. This is cosine over sine. So they had like fractions over fractions. They got common denominators. They moved everything around. And eventually they could prove the right and left side were equal. It just took a lot of steps to get them there, but it did work out. I don't know, maybe that's easier to you. Maybe you like the whole idea of sines and cosines and combining fractions. All right, questions, comments about what we did there?
This is like way too smart to do, so like, I don't,
Okay.
okay.
All right, moving on.
Thank you.
I like actual math more than this.
Yeah, exactly. This isn't math. This is just like,
Oh, it's math.
It's
no,
words.
it's like figuring out
It's
what's
words.
the point of
that though.
It's a
I
lot
can
of
do that.
words.
Why does
Heaven forbid I actually make you work. No,
I thought, why?
Okay, but Mr. Ward, would you agree that this is not as fun as normal math?
I like it.
This whole thing.
I bet,
I like this.
you don't like math that makes sense?
All right, here we go. Next one. Okay, now this problem, this one in particular, same with number 3 on your practice guide, or on your test, they won't tell you what the right side is. They're going to just say simplify it. It's not where we're trying to prove the right and left side actually work. We need to know what this thing is going to make in the end. These are very open-ended, lots of different strategies for it. These could be ones where you just have to combine fractions. It might be using common denominators. It might be changing things to sines and cosines. It's whatever strategy you need to simplify it as fast as you can. Like when I look at this problem, I could see it 2 different ways. Number 1, you could use conjugate rules on this fraction and that one.
Or sines and cosines.
Or change things to sines and cosines. That would be a second strategy you could do.
I like the conjugate rule.
But you need to figure out, because what I'm hoping this does is at some point, this thing will simplify down to like a single item. Either like the number 1, or it'll be like cosine in the end. It'll be a single item. Or maybe 2 items just side by side like that first problem we did. Where it's something easy to look at, not that. That is complicated. So I'll get you started. So on this particular problem, on this one, I would probably multiply by secant minus tangent
Good call, Mr. Ward.
on that, and on the top, same thing. Because I'm going to multiply by the conjugate. That way when I FOIL the bottom, it should work out to be one of my Pythagorean identities. And the top you can FOIL because it's just 1 there. Over here, I'm going to multiply this one by its conjugate, secant theta plus tangent theta. And I'll do that the same to the top as well. And I'll be able to FOIL the bottom, and it should work out to be a Pythagorean identity on the bottom, and on the bottoms here, so you'll be able to substitute these out. The top, you can FOIL that together. And then once they have common denominators, because the bottoms will simplify to be something, this will turn out to be something simple. I don't know if it'll be a number or like something. The top is this, right? This is what's on the top. So secant theta plus tangent. You'll be able to add straight across the top and then simplify those out. Okay? So that's my little hint. I'm not going to finish that problem out. I already did the first 2 for you to give you kind of an idea. This one you have to finish on your own. But I'm giving you an idea. It's going to turn out to be something simple on the bottom when you get this all worked out.
Square.
And when you add straight across, you should be able to simplify it. Okay? And it should work out to be a single trig function in the end. Okay, I'll let you have the rest of the time with that. Make sure you're writing that down. Okay, we're gonna go on to the next few problems. The next ones will require your property sheet, but I'll give you a little bit of time to write that down first.
What stuff were we supposed to use?
What did he say? Foil?
Or what?
You'll probably be using that.
The conjugate rule. So you can get a secant squared base.
Now, again, you could replace everything with sines and cosines if this doesn't work out for you. You have to get common denominators and do reciprocals and all that, but I'd say this is probably by far the easiest method of doing it, and it's faster.
Or I mean, those are tangent, secant, like what?
Yeah, the secant tangent ones.
Okay, so those first three problems were based on section 5.1.
Minus.
Okay, so I picked 3 problems from that. Something of each type. The next couple problems will be adding and subtracting, the sum and difference formulas. Those formulas are on your property sheet. They are up here. So if you're looking at your property sheet, the next ones we're going to do 4, 5, and 6. They're over here, the properties, the sum and difference. So we'll kind of walk through that. I'll do one of these for you, I'll let you do one by yourself.
Sure, this one is a lot harder than, number 3 is tough. The
Yes,
bottom
it is.
hard
I
to
don't know
do.
how
Is
it
it
is.
just secant? Is that the
Is
answer?
it secant squared?
Because when
secant
everything else
squared
cancels.
minus tangent squared is what it foils out to be. But then I
No,
literally
is
don't
the
know
other-
what that
isn't it
is.
the other way?
So you have to
No,
substitute.
it's
Use your property sheet.
minus tangent
Is it
squared.
2 secant of the angle?
Wait, is secant
Could be.
squared minus tangent
Oh,
squared?
that's the answer. I got it,
What is it?
everyone.
Could be. I'm not saying if it's right or wrong. Could be.
You're right,
That's
it's
your
eyebrows. I probably is right answer.
Okay, number 4.
2 secant of the angle.
Okay, we're moving on.
Of the theta.
Again, I'm not going to give you the answer for number 3. You're going to have to work that one out by yourself.
Mr.
Well,
Moore.
some people don't understand it, so.
So, that's fine. Sometimes it takes a struggle.
No, it's just.
I just want confirmation that I'm close.
I want confirmation I got the
Okay,
answer right.
number 4 and 5. I'm going to do one of these for you. These you can do by
Tangent.
sum or difference.
Do tangent.
Do the tangent one. All right.
It sucks.
Okay, so we're going to do the tangent formula for adding and subtracting. So you have to look at your property sheet, and you're going to have to use your unit circle and think of numbers that either add or subtract to make 105. I'm just going to pick one right now. I'm going to
60
use.
and 45.
Sure, that's what I was going to do. So we're breaking this up to tangent of 60 plus 45. So now you have to use your sum and difference formula that is on your property sheet to actually simplify this. My answer should be a fraction in the end. And you only have to go so far in this
I have a
problem.
question.
So,
Will you let us use this on our test?
property sheet?
Or this thing?
Yeah, that's fine. You can use that.
Wait, this we can use?
That's awesome.
You're allowed to use
Maybe
it.
we couldn't.
You told me we weren't.
It's the same one on the practice guide, so it's the same thing. It's got the same formulas. So, alright, so to do 60 and 45 on tangent. Okay, here's what you do. You have to use the tangent addition formula because we're adding here. These are the numbers we're choosing to add to make 105. So the tangent addition formula is this. Tangent of the first angle plus tangent of the second angle
It's on this thing.
over
Like this thing.
1 minus tangent of the first
I don't think.
Oh, I found it.
times tangent of the second. So that's your additions. That's your addition formula. Now to find tangent of 60 and tangent of 45, you'll need to have your special triangles somewhere. They'll probably be on the board. They'll probably be over there on test day. I'm just going to write them up on the board right now so you have them. So the 45, 45, 90 triangle is 1, 1, root 2. The 30, 60, 90 triangle.
Sorry.
The 30, 60, 90 triangle is 1, root 3, and 2. And now what I'll have to do is rattle off the tangents for those. So like tangent of 60 is, tangent means TOA, means opposite of 60 over the adjacent to 60. That's what TOA is, and why I know what angle to pick, they tell me the angle I'm using. So tangent of 60 is root 3 over 1, that's just root 3. So that's root 3, plus the tangent of 45, the opposite O over A, so opposite of 45 over the adjacent of 45, that's just 1 over 1. On the bottom, I have 1 minus, and now the two numbers I just found a little bit ago, so that's root 3 times 1. And if I simplify that, that's my answer, that's what you should get. Okay? Because you won't have to go any further than that, I just want the final fraction there. You don't need to do conjugates or anything like that for tangent. Tangent, you can just leave it, the two numbers there, top and bottom. But on sine and cosines, these usually work out to be like a single fraction in the end when you do those formulas. Just make sure that you know which formula to pick from. Okay, you're gonna have to do number 4 on your own.
I still don't get 3.
What's 6? Was that formula on there? What is that?
Yep, they're on there.
So,
They're on this side.
Wow.
Is that it for exams for what?
What?
No, he's doing a 7.
Right, we're doing 6 and 7.
We're doing one up.
We're doing 6 and 7 here.
and if we have enough time, we want to go back to 3.
Nope, I'm not going back to 3.
Are you sure you don't want to wait?
Definitely not.
Yeah. You can figure 3 out on your own.
I don't think we can.
Reese, you can. Pat can.
Yeah.
That is a Casio.
Huh?
Pat has a
Okay.
Casio.
Alright, let's go to number 6.
Two numbers.
You just plug it in the code.
Okay, alright, number 6. Here's what I'm going to tell you. So this one, if you read the instructions, they want you to simplify it down to a single trig function. Sine, cosine, tangent, I'll show you that here in a minute, what you do. And then it wants the actual answer for it. So what I mean by here, if you want to convert these angles down first, you can. I'll do that first. 7 times pi divided by 12, which if you convert, that's radians. So it's 7 times, to convert this, you take it times 180 over pi, the pi's would cancel. So you'll take 7 times 180 divided by 12, that's 105 degrees here. So this is cosine of 105.
Well, why can't you just put
Cosine of 180 divided by 12 is 15. Plus sine of 105, sine of 15. Alright, so I just converted them all to degrees. Now, you should recognize this formula. This formula is a sum and difference formula. And if you look at your property sheet or that little handout thing with all the little tabs on it, if you have that in front of you, this formula that you're looking at here is the cosine subtraction formula. Even though it has an addition here, this thing is equal to cosine of 2 angles being subtracted. If you look at your property sheet.
What it says.
So the angles you're using are these two. So this whole mess is equal to cosine of 105 minus 15. That's what it's equal to. That's, if you look at that property sheet, Carlos, it's right here, this one. Cosine of 2 angles being subtracted is the 2 angles being multiplied together on the inside with cosine and sine. So you can see it. So if I actually subtract 105 and 15, I get 90. So this is
Oh, Castaway. Let's watch it.
lost internet connection. Stupid Apple TV.
You want me to unplug the cord?
No.
It's cosine of 90. Cosine of
I
90.
told you.
No.
What's Jumanji?
Yes.
Alright. So subtracting this turns out to be cosine of 90. And then what you'll have to do is, since you're doing cosine, go find 90 degrees on your unit circle. Go find 90.
Found it.
And cosine will be the first answer at 90 degrees in the parentheses.
Pi 2.
No, that's the angle.
0.
0.
0.
Goose egg.
So we just write
0.
0 and then we write a bigger 0 around it.
0. That's your answer. Now the reason why, because when you find 90 degrees on that unit circle, 90 degrees is up here, you have to read off the coordinate that was there, and cosine is always the first answer.
Yeah.
Sine is always the second one. If you read off pi over 2, that's the angle they converted to radians.
I have a question.
Yes.
So for like sine and cosine of 45, they have root 2 over 2, but wouldn't it be root 2 over 1?
The idea is that for sine 45, it's 1 over root 2,
Oh.
and then they just got rid of the root 2 off the bottom, so it's root 2 over 2.
Gotcha.
Yeah. Alright. Questions on why they got 0. Okay, 7, last problem of the day. Last problem.
And then we'll go back.
Last problem of the day. Number 7.
Whoa.
I hate you.
Is Apple making you mad right now?
Yes, everything's making me mad right now.
Whoa. Even us?
Alright, so number 7. Cursor out of the way. Alright, so for number 7, you have to find these 3 answers. It's the double angles for this problem. So the trick is, you're going to have to go draw this triangle in whatever quadrant they recommend, and then you're going to have to set up your double angle formulas for each one. The double angle formulas are in your property sheet. They are in the middle of the bottom, the doubles. If you do cosines, cosine, I know on the formula sheet has 3 different ones. Just pick one that you're comfortable with. But these all have one simple trig function, and you're gonna actually solve it. So let me do like the first couple. You can do one of them on your own. To set this up, we're in the second quadrant. Okay, here's my second quadrant. Here's theta, I guess. Sine means opposite over hypotenuse. So if I put the opposite over hypotenuse in that second quadrant, this is the opposite wall, this is the hypotenuse wall. If I do the Pythagorean theorem, I'll figure out that the missing wall is -5. And again, if you don't know how that works, it's x squared plus 12 squared equals 13 squared. And then this is 144, and that's a 169. If you subtract this across, you get 25, and the square root of 25 is 5. But it's negative, yeah. And the idea is that how it works for that number, now that I have that triangle set up, now I can do each of these 3, because I'll just do let's do a couple of these. So let's do sine of 2 theta. So the 2 theta on your property sheet, like the formula for it is this. It's 2 times sine of theta times cosine of theta. That's the double angle formula that's on your property sheet. So all you have to do is go over here to this triangle and rattle off what these fractions are for sine and cosine and plug them into the formula. And that will give me the answer for the double angle. So sine on this triangle is, for theta, is 12 over 13. So 12 over 13. Cosine is the adjacent over hypotenuse, so it's -5 over 13. And then I'll just multiply straight across. You don't need to simplify the fraction or anything like that. I didn't require that on the homework. But if I'm multiplying these across, I'm going to get 169 on the bottom. On the top, I'm going to get 120. That's 2 times 12 times -5. Because again, if it's a big number, it just multiplies to the top. 2 times 12 is 24, times 5 is 120, and it's negative. That's my answer. That's the answer I'm looking for the sine. Now, I have to do cosine. So let's do the cosine formula. Now, cosine
Equals cosine squared theta.
Cosine has a couple different ones. You can pick whatever formula you wanted. I don't really care. There's one that's like cosine squared minus sine squared. There's one with 2 cosine squared minus 1. There's one minus 2 sine squared. Whatever one you want. Which one?
Cosine 2 theta minus 2 sine.
Okay.
Which one's the easiest?
Cosine squared, probably this one. Cosine squared minus sine squared.
Wow, I should pick this one.
That one? That's the one you want? I'd say it's probably the easiest. So I'm just going to plug in the numbers. We already know what cosine is. Cosine is, the -5 over 13. We figured that out earlier. That's the cosine of this triangle. But we're squaring it, because that's what little square means. We're squaring that fraction. And we're subtracting that from the sine squared. Well, sine on that triangle is 12 over 13. And we're squaring that. So you'll square the fractions. Again, how you square fractions, you square top and bottom each. So if I square these, I get, is that 25 over 169 minus, I square that to 144 over 169, and I can subtract it across. And I'll get a negative number, which is fine.
Oh, that should be -25 over.
No.
No, because when you square it, it's positive.
Yeah.
Stupid.
It'll be negative in the end. It's
Negative
fine.
119.
There you go. 119?
Yeah.
Okay. I get 1 over 169?
Yep.
Boom, done. Move on to the tangent one. So now you're going to use tangent, and tangent has its own double angle formula. You can see it on your property sheet. And you'll plug in your fractions in that one. That's the one you have to do by yourself.
What? Okay, man.
Okay. The rest of the time is yours. You don't have a lot of time. You can work on this. Now Monday we'll do the second half. We'll do double angles and all that good stuff. Tuesday, I should say, next week. Test is tentatively set for Wednesday. Again, I might just push it back to Thursday. Just so we get an extra day to work on this and review. But just make sure that you're working on this. Work on the book assignment. Don't wait till Tuesday night to start working on that book assignment, because you won't remember how to do any of that law of sine, law of cosine stuff. A lot of the problems had pictures drawn. There's only 1 or 2 that don't. But that's it.
Thank you.
So.